Hi there guys, so welcome back to my YouTube channel. So this is problem set number 4, theory of sets, permutation and combination, probability and statistics. So let's start for theory of sets. So a set is a well-defined collection of distinct objects. So basically a set can be set of numbers, objects, or anything that is well-defined. So sets involve different kinds of operations. So first, for example, here we have set A. You can consider this circle, the blue one, let's say this is set A, and this orange one, let's say that this is set B. So for these two sets to have a union, we have the notation A union B. So this is the notation for union. It means that, for example, for A we have let's say 1, 2, and 3, and for set B we have say 1, 3, 4, and 5. You can say that A union B, you can just combine these two. So we have 1, 2, 3 for set A, and for set B we have 1, 3, 4, and 5. So we can simplify this by writing the similar elements in the set only once. For example, 1 and 1, these are repeated, so we may just put it just 1. We have 1, we have 2, and 3 here is repeated, so we can write that down as 3. We have 4, and we have 5. So the union of A and B is 1, 2, 3, 4, and 5. So basically, we just have to combine the elements of each set and write repeated elements only once. For the second operation, we have the intersection. So what do you mean by intersection? It means that if this is set A and B, so it overlaps in this portion. So this portion is the intersection of A and B, intersections of set A and set B. So our notation for that is we have A intersection B. So we have the intersection of A and B. Say for example, we have for A, we have a sets of number 1, 3, 5, and 6. Say for B, we have, let's say, 2, 5, 3, and 1. You can say that the intersection of A and B are the elements that are common between the two sets. So we have, can compare, so we have 1 for set A, for set B, it also has 1. So it means that 1 is an intersection, we have 3, and we have 5. So the common between the two sets is its intersection. So another operation involves in set is the difference. So it is the minus. So we have, for example, we have here the two sets, so we have A minus B. So the difference between A and B, so it means that what are the elements that are in A but not in B. So you can we can interpret that. So we can interpret that in this figure. So we have A minus B is this portion. We need to subtract B from A. So this portion is actually A minus B. For example, we have for set A, we have 6, 8, 3, and 9. For set B, we have 4, 6, 9, 5, and 2, we can say that A minus B. So what are the elements in A that are not in B? So 6 is contained in B, so therefore it is not included. So we have 8. So 8 is in A but not in B, so we can write that down, 8. So 3 is not in B also but is in A, so we have 3. So 9 in A is contained in set B, therefore it is not included. It means that A minus B, that is 8 and 3. But what if, let's say, B minus A? So what are the elements in set B that are not contained in set A? It means that for set B we have 1. So 1 is not in A, therefore it is included. So we have 1. So 6. So they are both have the same element 6. So it is not included. 9. So they have both 9. So 5. So set A doesn't have 5. So means that it is included. And 2 is not contained in set A. So we have 2. So we have B minus A. The elements in B that are not in A is 1, 5, and 2. So the next operation is what we call a complement. So basically a complement are the elements that are not contained in a given set. For example, we have set A as we have the numbers 1, 2, and 3. So the complement of A are all numbers except 1, 2, and 3. Basically it is the elements, or basically those are the elements that are not contained in a given set. Next we have the Venn diagram. So for example, we have a set A, first set. So a Venn diagram is a representation of set using circle. So it means that this is the boundaries of set A. So it can be 2 sets or it can be 3 sets or more. So in this Venn diagram, let me explain this to you. So this middle part is the intersection of, so this is the intersection of A, B, and C. It means that this portion here, the elements contained here are found in set A, set B, and set C. So this portion is the intersection between set A and set C. It means that the elements here are both contained in A and C. So this portion is the intersection of B and C. It means that this portion, the elements in this portion are both contained in B and C. And same as here, the intersection of A and B. So this part here, the remaining part, so these are the sets that are only contained in A, and this portion are the only element contained in B. So in this portion, the only element that is contained in set C. So let us apply this theory of sets for solving problems. For example, here we have, in a class of 40 students, 27 like calculus and 25 like physics. How many like both calculus and physics? So let's say this is the set of students for calculus and this portion is for physics. So we can let X be the intersection of the two sets. So we are required to find the intersection between these two because we have both calculus and physics. So this is the intersection. So this portion, this circle, should have a sum of 27 students. So meaning this remaining part, this is 27 minus x. And this remaining part here, this is 25 minus x. And the sum of this 3 should be 40. So we have 27 minus x. We have plus x plus 25 minus x, that is equal to, we have 40 students. So we have 27, so we have negative x plus x, that is 0. So we have plus 25 minus x is equal to 40. So we have x equals, so this is, we have 52 minus 40. So that is, we have 12. So 12 students both like calculus and physics. So 12 is the intersection. So you can write this. This is 12. So we have 27 minus 12. We have here 15. So we have 25 minus 12. We have 13. You can check this. You have 15 plus 12 plus 13, that is 40. So for the second problem, we have, in a commercial survey involving 1,000 people on brand preference, 120 prefer brand A only, 200 prefer brand B only, 150 prefer brand C only, 370 prefer either brand A or B but not C, 450 brand B or C but not A, 370 brand C or A but not B. So the question is, how many of the people has no brand preference? It means that they can choose A, B, or C. So we are required to find the intersection between three sets. So let's have this. Let's say for this is set A, we have set B, and set C. So we are required to, let's say, let X be its intersection. Okay, so we have, for the first condition, you have 120 prefer brand A only. So this is the portion that is for A only. So you have 120. So 200 prefer brand B only. So we have B. So this is 200. So 150 prefer brand C only. So I have here 150. So we have the next condition. We have 370 prefer brand A or B but not C. So it means, or what are the portion A or B? So this is the portion A or B, 120. This part, the intersection between A and B, and this part. So the sum of these three should be 370. So to make this 370, the intersection should be, we have 50. You can check that out. 120 plus 50, that is 170, plus 200, that is 370. We have next, we have 450 prefer brand B or C but not A. So these three should be a sum of 450. So to make this 450, the intersection between B and C should be, we have 100. So you can check this out. You have 150 plus 100, that is 250, plus 200, that is 450. And for the last condition, we have 370 prefer either brand C or A but not B. So the sum of these three, so you have A or B, this is A or B, this portion, the intersection between A and C, and this portion. So the sum of these three should be 370. So this portion should be, you have 100. You have 120 plus 100, 220, this plus 150, that is 370. So the total of this should be, you have here 1000. So you have 1000 equals, so you have 120 plus 50 plus 200 plus 100 plus 150 plus 100 plus x, that is equal to 1000. So solving for this, we have 1000 equals, we have here 720 plus x, so we have x as 280. So the intersection should be, we have 280. So let's proceed to combination and permutation. So when you say permutation is the ordered arrangement of a finite number of elements, and combination is the arrangement of the selection of objects regardless of the order. So the only difference between these two is that permutation considers the order, but combination does not. For example, you have numbers 1 and 2. So 1 and 2 can be written as 1 and 2, and you have 2 and 1. So you have two different permutation. So these two are different when you are talking about permutation. For combination, 1 and 2 and 2 and 1 is only one combination. So even if this is in different order, as long as the elements are there, it is considered as the same. For example, we have this, the number of permutation and combination of n different things taken are at a time. You can say that if you have n number of elements, you have permutation. If you take r at a time, you have n factorial all over n minus r quantity factorial. So for example, we have, if you have 6 elements in a single data, and you take 3 at a time, you have 6 factorial over, you have 6 minus 3 factorial. So for combination, it is different. We have n number of elements taken r at a time. We have n factorial over r factorial times quantity n minus r factorial, or we can put this as npr over r factorial. So we can say that this portion is just npr. So we have the first problem. There are 5 balls of different colors. 3 balls at a time are taken and arranged in any way. How many such combinations are possible? You have NCR, that is n factorial over r factorial times n minus r factorial. So we have n as 5. You have 5 different balls. You have 5 C. You have 3 balls taken at a time. So you have 5C3. We have 5 factorial all over. We have R, that is 3 factorial times 5 minus 3 factorial. So that is 5 times 4 times 3 times 2 times 1. You have 3 factorial, that is 3 times 2 times 1. And 2 factorial is just equal to, you have 2 factorial. You have 2 times 1. See, the 2 times 1 will cancel here. You have 3 will cancel here. You have 5 times 4, that is 20 divided by 2. So you have 5C3 as 10. You can also use your calculator to solve this automatically. So we have 5. So for combination, we have shift divide. We have shift divide, that is combination 5C3. We have 10. For next problem, we have in a machine design examination, a student may select 6 problems from a set of 9 problems. In how many ways can he make his choice? So this problem is a combination problem since, so even though that the student chose 6 different problems in 6 different orders, it is always considered as the same set of problems. So as you have 9 shift divide, that is 84. So we have 84 ways. You can choose 6 problems out of the 9 problems in a machine design exam. In how many ways can you invite one or more of your 5 friends to a party? So we have NCR. So for N you have 5. But in the problem it states that one or more, you can invite one or more of your 5 friends. So meaning you can take R as 1 at a time, you can take it 2 at a time, or 3, 4, or 5 at a time. It means that the number of ways you can invite one or more of your 5 friends to a party is the sum of this combination. So you can say that you can invite your friends one at a time. You have 5C1 plus you have 5C2, 2 at a time, plus 5C3 plus 5C4 plus you have 5C5. Alternate solution for this kind of problem. So we have one or more taken at a time. So we have the combination equals, we have 2 raised to n minus 1. So you have C equals, so 2, you have n as 5 minus 1. So you have C equals, so you have 32 minus 1. So that is 31. So this is an alternate formula for this kind of problem. You have taken one or more at a time. So this is the fastest way in solving this kind of problem. So how many permutations are there if the letters E and G are taken 4 at a time? So we have here permutation. So we have N P R. So we have N as 5. We have N equals 4. So that is 4 letters. 1, 2, 3, 4. You will take that 4 at a time. So you have 4 P4. So that is equal to, you have 4 factorial over, you have 4 minus 4 factorial. So that is equal to So you have 4 times 3 times 2 times 1 over 0 factorial. So that is 4p4 is equal to, you have 4 times 3, that is 12 times 2, that is 24 over, you have 0 factorial, that is 1. So you have 24. You can also use your calculator to solve this. So for permutation, you have shift multiply, so that is shift times. So in how many ways can 7 distinct books be arranged in a bookshelf? So if you arrange the books in different order, it is considered as different. So it means that this is a permutation problem. So you have NPR, so that is n factorial over n minus r factorial. So you have 7 books, so you have 7 all over, we have 7 minus 7 factorial. So we'll take that 7 at a time. You have 7 factorial over, so you have 0 factorial, that is 1. So we have 7 factorial, so that is, so in your calculator we have, so in the calculator we have 7. So for factorial we have shift x raised to negative 1. So we have shift x raised to negative 1, that is factorial. So we have 7 factorial, that is 5040. So we can also say that, so we can also use 7, you have shift multiply 7, so we have 5040. Find the largest number of permutations of the letters in mathematics. So for this kinds of problem, we have the formula. You have n Pn all over, you have r factorial, s factorial, q factorial, and so on. So this rs and q are the number of times a letter is repeated. So a number of times letters, different letters are repeated. That means that for this problem, we have n as, so that is 1, 2. For mathematics, word mathematics, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have 11 letters. So for R, let's say R, so M is repeated, so you have, it is repeated 2 times, so you have 2. So the letter that is repeated is, you have A. A is repeated 2 times, so let's say that is S. So we also have T, that is also repeated 2 times. So we have a complete given. So we have NPN, that is, you have 11 P11 over 2 factorial times 2 factorial times 2 factorial. So we have, so we have 11 P11 over, you have 2 factorial times, you have 2 factorial times 2 factorial. We have 4,989,600. So in how many ways can 6 people form a circle? So this problem is called a cyclic permutation. It means that if you form a circle, you have 1, 2, 3, 4, 5, 6. So you will be having one starting and one end. So this will be your reference point. So this person is your reference point. So we have the formula for cyclic permutation, that is, you have the permutation for a cyclic permutation that is given by n minus 1. You have factorial. So we have p equals, so for this problem we have 6, that is 6 minus 1 factorial. So we have 5 factorial. So that is 5 times 4 times 3 times 2 times 1. We have 20 times 3, that is 60 times 2. So that is, we have 120. Well, that's it guys for the first part of this problem set number 4. Part 2 will be coming out soon. And once again, if you like my videos, like, share, and subscribe on this channel. So you can also follow me on my Facebook page, Mechanical Engineering Review and Calculator Techniques. See you guys!